Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello STAT students, and welcome to the video presentation for hypothesis testing. My name is Janine Allwright, and I am the instructional specialist at Walden's Academic Skills Center, where I lead the statistics tutoring team. In this video presentation, we will continue to lay the foundational understanding of inferential statistics. We will discuss the why and the how of research questions and hypotheses, and we will review the 95% confidence level one more time in more detail and relate this to the regions of rejection under the curve and statistical significance. I will also briefly talk about type 1 and type 2 errors and show the interaction between both with another awesome Magnusson resource. I will also discuss what it means for significance and the rejection of the null hypothesis when the confidence level is adjusted up or down. And I will explain what that means for the quality of research. Lastly, we will look at meaningfulness versus significance, and we will practically evaluate both with a simulated research scenario where we will also talk about sample size and social change. This video presentation will not include live SPSS presentations, but is merely a theoretical explanation of the statistical concepts that relate to hypothesis testing. Now let's get started. Now, as you probably know by now, we use smaller samples as stand-ins for greater population. And we want to ask ourselves, what do we want to learn about that population? In other words, what is the research question? Research questions can have different natures. They can be descriptive, they can be comparative, they can be relational or predictive. And I'm sure we can find a couple more words here that would describe the nature of research questions. The comparative, relational, and predictive research questions will be presented in later videos in this video series. But please be sure that your research question is a question and has a question mark at the end. It is not a statement. You are to translate your research questions into two hypotheses. But I want to mention here that sometimes I hear students start research questions with the words what or how. And as far as I know, and within the training that I received, those words belong in a qualitative research question. I was taught during my dissertation process by my chair to use the phrase to what extent. That will prevent that you quickly answer a research question with yes or no, and it allows for a little bit more nuance in the interpretation. I've also seen research questions that start with the word does. Hypotheses are different. We have to learn what we are going to test. That is the purpose of a hypothesis. We want to answer those questions about the greater population, right? Now, why do we need these hypotheses? We need to know what we're testing. The first hypothesis that I always formulate is called the alternative hypothesis. It states what I'm expecting to find, what I'm hoping to learn. Often it follows the literature. The null hypothesis is the hypothesis that we are testing in SPSS. It states the exact opposite of the alternative hypothesis. They form a pair. One research question is translated into two hypotheses, so please make sure that you include both when you write assignments. Now let's look at the null hypothesis with a bit more detail. As it states the opposite of the alternative hypothesis, it is a statement of denial. Often it has the word no or not in it. It includes the variable names. replace IV before DV. That is an unwritten rule. If you forget, I will remind you of that in future videos. And it often includes a reference to the test. And I'm grabbing back to those research questions that I mentioned earlier. It could have the word difference in it for a comparative research question, or it could have the word predict for a predictive research question, and so on. A hypothesis is different from a research question. It doesn't get a question mark, and it's just a statement. On the next couple of slides, I'm going to show you a refresher of some of the theory of hypothesis testing. This is by no means meant as a complete picture. I trust that you've studied the statistical literature that is available to you in the classroom. But the testing of the hypothesis corresponds with an area under the curve. And as you can see here, we call these the critical areas. I can test in one direction. I can hope with a one-tailed approach that I'm looking to see if my population mean is going to come out smaller than a set value. I can also look on the direction here on the right where I'm hoping that my population mean is going to come out greater than some set value. If I'm indifferent about the direction, then I can just see if my population mean is going to come out differently from another population mean, maybe. The x-axis here could be represented by z-scores, it could be represented by t-scores, or even by f values. It's depending on the test. It's not meant to hold p-values, but the area under the curve, the blue area, corresponds with the p-value. And this ties in with the type 1 error that I talked about in an earlier video, where the alpha level is set to 0.05. That's 5% chance of making a mistake. That is the maximum that I will allow in the field of social science. And I want to come out below that so that I can reject my negatively formulated null hypothesis. This relates directly to those p-values, and if I would graph them out on a line, it would look something like this. I have a 95% confidence interval that results in a 5% leftover. That's my alpha level. This is not a graph, but merely a line. I'm going to place that on my line. And what happens here is then when my p-value that we get from SPSS is greater than 0.05, I'm going to hang on to that negatively formulated null hypothesis. And I found non-significance. If my p-value is smaller than 0.05 and in that safe zone smaller than the type 1 error, and I may reject my null hypothesis. Now, what makes this difficult is working with a negatively worded null hypothesis. In essence, when you reject a negative null hypothesis, that means you're turning it around and you're going to eye the alternative hypothesis. Don't worry if this is not yet percolating for you. We will spend time with every test in this video series to practice with these p-values and to evaluate these null hypotheses per test. Now, you have heard me mention the type 1 error a couple of times already on this video, and I talked about it on the previous video as well. That relates to that alpha level here on the screen. The golden standard is 0.05, right? We set that at 95%. Now, what does that really mean to generate a type 1 or a type 2 error? A type 1 error is when we have a null hypothesis that is true, that we properly retain. That is in the green area here, right on, we're doing a good job. The same goes when our null hypothesis is not true, when it's false, and we rightfully reject it. The errors come in play in these pink areas here, where we have a true hypothesis that we accidentally reject. That's a type 1 error. Or a false hypothesis, false null hypothesis that we accidentally retain. Now, a type 1 error is what we call an alpha. A type 2 error is what we call a beta, but we annotate that with the word power. Power is 1 minus beta. Both alpha and the power are set in the field of social science at respectively 0.05 and 0.8, 80% power. These two values interact. If I'm trying to reduce a type 1 error, I'm probably going to increase my type 2 error and vice versa. I want to show you what that looks like with another of Magnusson's interactive approaches. This is a different website than last week, but in the same series. And here we are. I will make sure that this website is linked in the transcript. And I want to urge you to read the text that is a part of this website. I'm not going to spend as much time on this website as I did in the previous video. I just want to show you that interaction between the power and the significance level, the alpha and the beta in essence. Keep in mind that the power really is 1 minus beta. You could see this as two group comparisons here. What happens between those two groups? My power is the light blue area. The red area is my significance level. And if I change my significance level, if I increase my alpha to, let's say, 0.1, and I set my confidence level at 90% with a 10% chance of making a mistake, you saw the curve move there. Of course, my red areas will increase. Let's go back and look at that one more time. They're much smaller here, right? Everything moves a bit. And my left blue area is being sliced a bit by that dark blue and that red. So you see that interaction there. If I change my power, if I reduce my power to 60%, in essence, one could state that the test becomes less powerful, and there it goes. It's like the curve walks itself to the left side a bit. I want to encourage you to come back to this page and really move these sliders around so you get an idea of that interactive um, relationship between those values. This is actually a representation of a t-test. The Cohen's d here shows that effect size between those two groups. I'm not going to get too deep into this, but I will remind you in a future video when I talk about the t-test to come back here and look at these interactions again. Now that we've learned about that relationship between power and significance level, I wanted to take you back to the PowerPoint and show you what the change of significance level, specifically changing the confidence level, means for our hypothesis testing, for the result of where that null hypothesis is going to be rejected or retained. And here is our PowerPoint again. What happens when I change those confidence levels, right? I showed you this setting before. This is the golden standard. I set my confidence level at 95%. This does not represent a line of a graph. This is just a line to show where that point of 0.05 is. This is my alpha level, that threshold against which I will compare these calculated p-values that SPSS will produce for us. On the right side, I'm dealing with non-significance. I will retain my negatively formulated null hypothesis, p greater than 0.05. And on the left side, I will reject that null hypothesis. And I have significance. When I drop my confidence level to 90%, I will get a different alpha. My alpha will increase. It's that leftover. It's that 10%, also annotated with alpha is 0.1. Now I can see here that that is higher up on this line, on this horizontal line. In essence, I have the same situation. When p is greater than alpha, when p is greater than 0.1, I am venturing into the area of non-significance, and I will have to hang on to my null hypothesis. On the left side, I will find significance, and I can reject my null hypothesis. But look what this means now for that area of significance. I've added this red area as a possibility to land. I've moved the bar. I've increased my alpha level, but I've also increased that path on where I can reject my null hypothesis. And under that statement that 95% is my golden standard, 90% just will not be enough. If you set your confidence level to 90%, you truly are tampering with the alpha level, and you're increasing the odds that you will reject the null hypothesis, and we cannot accept that in the literature. If you read a research article or a footnote or anywhere where a researcher is stating that they are dropping the confidence level to a lower level, maybe because they're engaging in exploratory research, that happens. But exploratory research is often done just to get your feet wet. It truly has to be exploratory in nature. Naming it exploratory doesn't necessarily make it so. You have to critically evaluate that. It is always a red flag moment. That doesn't mean that exploratory research does not exist, but usually it will not drive policy decisions. So it's for you to critically evaluate that when you see such a situation happening, and critically evaluate why a researcher might be moving the bar. In the same sense that we can drop the confidence level, we can also increase the confidence level. We often see that in the field of medicine. If I set the confidence level to 99%, I'm going to end up with a much smaller alpha level. It's portrayed here on the left side. I have a much greater area to retain that null hypothesis to find non-significance, and a much smaller area for significance. I have that decrease in alpha. And in the medical field, we're dealing with maybe treatments, medication, we're dealing with live participants. So we don't want to make a mistake because that will have grave consequences for our participants. And that's why we set the confidence level very high there, 99%. Sometimes it's even set to 99.9%. Now let's talk about meaningfulness versus significance. We now know that the definition of significance in statistics only means one thing. It is that comparison of that p-value to that set alpha level to evaluate whether we're going to retain or reject our null hypothesis. That is the only meaning of the word significance in statistics. I've mentioned before that in one of the earlier videos that sometimes in statistics we use words that in our common everyday vocabulary mean something else. Well, here is an example of that. When I look up the word significance in the dictionary, and I did that for us here, it shows the definition here. It shows a certain importance, a meaning. What is the meaning? What is the sense? What is the magnitude? What is the weight of it? What's the consequence? But when we evaluate scenarios or research studies for meaningfulness, that actually sounds a lot like the dictionary defines significance. So think about meaningfulness versus statistical significance. These words mean something different in statistics than they do in our everyday vocabulary. Again, to summarize, statistical significance only relates to that comparison of p to alpha. Meaningfulness has that mention of worthy. Is it worthy of attention? We can have situations where meaningful and significance are separately assessed. And there are 4 scenarios that you can think of there, 4 possible outcomes. You can have an outcome that is significant and meaningful. You can have an outcome that is significant but not meaningful. I can even think of insignificant results, but they're still meaningful. And we can think about insignificant results that are also meaningless. They have no meaning. To illustrate some of these examples, I want to show you a simulated scenario that I wrote for the purpose of this presentation. And I'm going to bring this up on the next screen, and I want to encourage you to just put the video on hold for a moment and to absorb what's going on here in this scenario. I will make sure that this text is also copied in to the transcript so that you can read along. This is a scenario of very small children in kindergarten and first grade that are being evaluated for their short-term memory. We have 20 girls and 25 boys from schools in one school district. Now the teacher is evaluating these young students for word memory and retrieval skills. The researcher decided to relax the confidence level to 90%, thereby increasing that area to find significance, right? That area to reject that null hypothesis, as I just explained. There are some results here that we have not yet learned what they exactly mean, but I can see that there's a p-value mentioned here, and there's a conclusion here about significance and meaningfulness, and a last sentence that relates directly to social change. I'm going to evaluate this scenario for 4 points. I'm going to talk about the sample size. I'm going to talk about statistical significance. I'm going to talk about meaningfulness and social change. And you see these 4 concepts here color-coded, and the reason is that I've actually color-coded how it relates to our scenario. And you can see here on the scenario how these colors came out for those 4 concepts. Sample is blue, significance is purple, meaningfulness is green, and social change is yellow. Now, when you critically evaluate the scenario, I want to point out that this is a flawed scenario. The sample size is flawed. There's something off with the significance. It's not very meaningful, and it's limited for social change. Let's start with the sample. Oftentimes, students think that you have to have equal group sizes. That is not necessary. We will learn later in this video series that this fits nicely in a t-test. But the issue with the sample size is that it is selected in one school district only. That already makes me question this sample, because that means that I'm probably not going to be able to generalize the results to a greater population. If this is a kindergarten and first grade in the United States, then I'm a bit limited with that one school district and hesitant to generalize that to other areas in the country. And that is a real issue with this sample size. The total sample size of 45 also seems a bit small. At undergraduate level, we are oftentimes taught that a healthy sample size is at least 50. That is a number that we have to let go of here at the graduate level. Sample size calculation is actually a rather complicated calculation. At dissertation level, we use the G-power calculator for that. That is a calculator that is designed by the University of Düsseldorf in Germany. And when you come to dissertation time, you will engage with that. But for the sample size calculation, we need a lot of components, and we do not really set minimum numbers. Nonetheless, the conclusion is that this is not a very representative sample, which will limit our ability to generalize across the greater population, and it's a small sample size. Now let's move to our statistical significance. I can see here that the researcher calls this exploratory in nature and uses that as a reason to relax the confidence interval to 90%, in essence, moving the bar. Just because the researcher calls it exploratory doesn't make it so. I personally think that these kinds of insights, these kinds of research studies have been done already. There's not much exploratory here. The field of education is very well developed, and I can imagine that this is not the first time that we have compared short-term memory scores for a small sample of boys and girls. So I would not call this exploratory in nature. So I question the fact that the bar has been moved. As I showed on that earlier slide, and I will bring that slide back up here, 0.069. If I had set the confidence level or kept that confidence level at a responsible number of 95%, I would have had to retain that null hypothesis. But that 0.069 fits nicely to the left side of 0.1 in that red area of increase in alpha. And look how nicely that worked out. The researcher was able to reject the null hypothesis. The researcher calls the results significant because they represent a measure of IQ, but we know that the results are only significant because in statistics, significance means comparing the p-value to the set alpha level. Now let's talk about the meaningfulness. Is this meaningful to measure young kids for short-term memory as a representation for IQ? As far as I know, we do not execute IQ tests on our young kids, so that makes it less meaningful. It's also not very meaningful to move that confidence level. And I'm sure you understand now that some of these concepts, such as meaningfulness, is not really black and white. I can tie it in with the sample size and I can tie it in with the significance. It's not very meaningful to just select one school district. It's not very meaningful to have a small sample size. And the results are not very meaningful because I've moved the bar. And, representing a measure of IQ for such small children is not very meaningful either. My last color, the yellow color, relates to social change. And I want to point something out to you that oftentimes happens in these flawed research studies, is that these, let's call them flawed results, are now being used to drive social change. It looks like these researchers or researcher are motivating us to, bring additional memory training to the boys in kindergarten and first grade. That is based on erroneous results, really. This was not really an exploratory study. And so you should really question the social change element of this scenario. This was just a brief simulated scenario to show you how you can evaluate those 4 concepts here in research studies. And if you see a scenario like that, find those red flag moments. Find those areas where you question what the researcher is really doing here. Have bars been moved? Has text been changed? Are sample sizes adequate? And is there truly an element of social change? And with this explanation of this simulated scenario, this video presentation has now come to an end.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mail.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.